Have you ever wondered how humankind will feed itself in the future when expanding into the vast expanse of space? An intriguing question, isn't it? But it's not just a question of science fiction anymore. As we venture further into the cosmos, it's a question we must answer. The future of food production is a topic that's growing in importance. No longer confined to the Earth, we're beginning to explore the challenges and opportunities of agriculture in space. Traditional farming methods that we've used for thousands of years, those that rely on soil and gravity, simply won't work in a zero-gravity environment. Imagine trying to plant seeds in a field where they float away instead of nestling into the earth. Or picture water droplets hovering in the air instead of soaking into the ground to nourish crops. Even the most basic elements of farming become complex problems in the void of space. But just as humanity has always done, we're finding ways to overcome these challenges. The need for innovation is clear, and researchers are rising to the occasion. They are exploring techniques like hydroponics, where plants are grown in nutrient-rich water instead of soil, and aeroponics, where plant roots are misted with nutrients while suspended in air. These cutting-edge methods are not just theoretical. They're being tested and refined in labs and aboard the International Space Station right now. And they're showing promise for helping us sustainably produce food for long-duration space missions and future human colonization of other planets. On top of these, vertical farming, where crops are stacked in layers to maximize yield per square foot, is another method being considered. This technique could be particularly useful in space, where every inch counts. So, as we look toward the stars and dream of distant worlds, we're also looking at how to feed ourselves once we get there. It's a fascinating journey, one that's only just beginning. The future of food production in space lies in the hands of several innovative techniques, and we're excited to see where these innovations will take us. Imagine growing plants without the need for soil. Sounds like something from a science fiction novel, right? Well, it's not. Welcome to the innovative world of hydroponics, a technique that enables us to grow plants sans soil. In hydroponics, the soil's role as a nutrient provider is replaced by water. Plants are grown in a water solution that is rich in essential nutrients. These nutrients are directly absorbed by the roots, which are exposed to the nutrient-rich water. The idea is to provide plants with exactly what they need when they need it, maximizing their growth potential. But why ditch the soil, you might ask? It's all about control. By removing soil from the equation, we can control the environment and the nutrients the plants receive. This means we can optimize conditions for plant growth and productivity, reducing the incidence of soil-borne diseases and pests. Now let's take this concept and apply it to a seemingly impossible environment for plant life: space. Picture this: astronauts on long-duration space missions far from Earth's familiar soil, growing their own fresh produce. It sounds far-fetched, but hydroponics could make it a reality. In the microgravity environment of space, traditional soil-based agriculture is not feasible. However, hydroponics doesn't require gravity to deliver nutrients. The water solution can be circulated around the roots, providing the plants with the necessary nutrients and oxygen. Additionally, this method saves precious space, a valuable commodity on a spacecraft. Hydroponic systems can be stacked vertically, allowing for efficient use of available space. But it's not just about survival. Fresh produce can provide astronauts with vital nutrients that are lacking in prepackaged space food, improving their overall health and well-being. Moreover, the psychological benefits of tending to a garden and eating fresh food in the harsh environment of space should not be underestimated. Hydroponics offers a promising solution for providing fresh produce to astronauts on long-duration space missions. This technique could be a key piece in the puzzle of sustaining human life on other planets, transforming our galactic dreams into reality. What if we could grow plants with just air and water? Now that sounds like something straight out of a science fiction novel, doesn't it? But hold on to your hats, because this is not just a wild fantasy. It's a reality that's taking shape in the world of space farming. We're talking about aeroponics, a method of growing plants in an air or mist environment without the use of soil. It's quite a remarkable concept, really. Imagine plants suspended in air, their roots misted with nutrient-rich water, flourishing in a microgravity environment. That's aeroponics for you. The beauty of aeroponics lies in its efficiency. It requires less water than hydroponics, another popular soilless cultivation method. This is a significant benefit, especially when we consider the constraints of space travel, where every drop of water counts. But the advantages of aeroponics extend beyond just water conservation. In a microgravity environment like that in a spacecraft or on the Moon or Mars, soil can be tricky to manage. It can fly around, get into equipment, and generally be a nuisance. Aeroponics eliminates the need for soil altogether, making it an attractive proposition for space farming. And it's not just theory. NASA has been experimenting with aeroponics since the late 20th century. They found that plants grown through aeroponics are healthier and grow up to 3 times faster than their soil-grown counterparts. Moreover, aeroponics can be combined with vertical farming techniques, allowing for a high yield within a limited space, a critical factor for space missions and future colonies on other planets. So we're not just talking about growing a few salad leaves here. We're talking about the potential to sustain long-duration space missions and future human colonies on other planets. With the potential to save more water and resources, aeroponics might just be the future of space farming. It's a brave new world out there, and we're just getting started on this exciting journey. Let's see where it takes us. How do we maximize agricultural yield in the limited space of a spacecraft or space station? A question that has perplexed scientists and astronauts alike, but the answer might lie in an ingenious method known as vertical farming. Imagine a garden, not spread across the ground, but reaching up towards the sky. This isn't a scene from a futuristic sci-fi movie, but a reality we're striving to achieve in our space missions. Vertical farming is a method of growing crops in vertically stacked layers, rather like a multi-story car park for plants. It's a game changer for space agriculture, turning the traditional flat fields on their side and allowing us to grow more in less space. The beauty of vertical farming lies in its flexibility and adaptability. It's not just about stacking shelves of plants on top of each other. It's about maximizing every possible inch of space. Think of it like a game of Tetris, but instead of fitting blocks together, we're fitting plants. And these plants aren't confined to the ground. They can grow on walls, ceilings, anywhere we can find a spot. But how do we water and feed these vertically grown plants? That's where hydroponics and aeroponics come in. Hydroponics is a method of growing plants without soil, using mineral nutrient solutions in a water solvent. Aeroponics, on the other hand, is the process of growing plants in an air or mist environment without the use of soil or an aggregate medium. Both methods are perfect for space, where soil is in short supply and water is a precious resource. Imagine a lush green garden, flourishing not in a field, but in a spacecraft, in the middle of the vast emptiness of space. This isn't just a beautiful vision, but a vital one. We need to be able to sustain ourselves on long-duration space missions, and if we're ever going to colonize other planets, we need to be able to grow our own food. Vertical farming could be the key to sustaining large spacefaring populations in the future. A future where the stars are our fields, and our gardens reach not just towards the sun, but amongst the stars. What does the future hold for space-based agriculture? As we journey towards the finale of this cosmic exploration, let's recap. We've taken a deep dive into the future of food production, experimented with soilless cultivation, and even maximized the use of space in space itself. Now we hover on the brink of the future, gazing into the vast expanse of possibilities that space-based agriculture presents. The research in this field is as expansive as the universe we seek to inhabit. Scientists around the globe are working tirelessly, experimenting with hydroponics, aeroponics, and vertical farming, in a bid to create sustainable food production systems that can withstand the harsh conditions of space. But why, you might ask, are we so invested in space farming? The answer lies in our innate human curiosity, our insatiable thirst for exploration, and our relentless pursuit of survival. As we set our sights on long-duration space missions and even human colonization of other planets, it becomes increasingly essential to develop efficient, self-sustaining food production systems that can thrive in extraterrestrial environments. We are not just talking about feeding a handful of astronauts on a spaceship, but potentially sustaining entire human colonies on other planets. The stakes are high, but so are the rewards. Imagine, if you will, a bustling Martian colony complete with lush vertical farms producing fresh food for its inhabitants. This is the dream that fuels the ongoing research in space-based agriculture. But it's not just about survival, it's also about sustainability. The techniques being developed for space farming can also be applied here on Earth, potentially revolutionizing our current agricultural practices and promoting a more sustainable future. In conclusion, the prospects of space-based agriculture are as boundless as the cosmos itself. As we continue to push the frontiers of human knowledge and capability, we are not just creating new ways to survive, we are redefining what it means to thrive. As we venture further into space, the techniques we develop today may be the cornerstone of human survival in the cosmos.